am Revati Bhavikati. In this video, I am going to explain you about how we will be exploring foundational concepts in science and technology with a specific focus on linguistics in ICAS. We will particularly examine the computational genius behind Sanskrit, a language that contains remarkable systematic structures and logic. In this video, we will cover 10 key areas that connect Sanskrit linguistics to computational thinking. We will begin with an introduction to linguistics in ICAS, then explore the components of a language, examine Panini's groundbreaking work on Sanskrit grammar, and study the scientific approach to phonetics in Sanskrit. We will also look at patterns in Sanskrit vocabulary, computational concepts in Ashtādhyāyī, language for sentence construction, the importance of verbs, Sanskrit role in modern natural language processing, and finally summarize the implications of these ancient systems for a modern technology. It's important to understand that in Indian tradition, language was never seen as just a communication tool. It was created as a scientific medium for a knowledge representation. Sanskrit in a particular stands out best because it highly systematic and rule God. Today, we will focus on three key aspects: Panini's grammar, Sanskrit phonetics, and computational logic, all of which contributed foundational ideas that resonate with modern science and technology. These systematic approaches to language developed over 2500 years ago demonstrate remarkable insights that parallel modern computational thinking. In any language study, we recognize several fundamental components. Phonology deals with the sound, vowels and consonant and intonation patterns. Morphology examines how words are formed and structured. Syntax addresses the rules for constructing proper sentences. Semantics explores how meaning is derived from words and sentences. Finally, pragmatics look at how context affects language usage. What's remarkable is that these components were systematically codified in Sanskrit over 2.5 millennia ago, long before modern linguistics emerged as a discipline. This early systematic approach shows the scientific rigor applied to language studies in ancient India. Panini was truly a pioneer in formal grammar. His work, the St. created around the 4th century BC, consists of approximately 400 sutras or rules. What makes this work remarkable from a computational perspective is that it utilizes concepts like meta rules, recursion, and back referencing, all characteristics we associate with modern computer languages. Panini essentially defined a generative grammar creating rules that could derive all valid Sanskrit sentences. He introduced sophisticated concepts like Sandhi, sound changes at word boundaries, Samasa, compound formation, and Kuraka theory, which deals with case roles in sentences. This level of formalization was unprecedented for this time. Sanskrit phonetics represents one of the earliest scientific approaches to sound production in human language. The field of Shiksha, one of the 6 Vedanga or auxiliary disciplines of Vedic study, focuses specifically on phonetics and correct articulation. Sanskrit sounds are meticulously classified by place of articulation, whether they were guttural, produced in the throat, palatal at the hard palate, reflex with a tongue curled back, dental at the teeth, oral labial at the lips, They are also classified by manner of articulation, whether they were wise or unwise, aspirated or unaspirated. This scientific approach to speech sounds are influenced modern speech therapy, AI-wise design, and linguistic studies. The precision in describing exactly how each sound is formed remains impressive even by today's standards. Sanskrit vocabulary demonstrates remarkable semantic precision and systematic word formation. Words in Sanskrit are derived using roots called ditas combined with various suffixes. These systems allows for precise meaning generation and the formation of multiple related words from a single root. This systematic approach to word building creates clear semantic relationship between related concepts, which greatly aids natural language understanding. Modern computational linguistics uses similar approaches when building semantic networks and ontologies. Panini essentially functions as an algorithm for functional generation. It follows a computational model of input transformation through rules and output. The system includes meta rules which govern how other rules are applied similar to functions in modern programming. It also contains context sensitive rules that produce different outputs depending on the surrounding elements. In many ways, this is represents an early example of what we now call an infinite state automaton and rule-based artificial intelligence. The systematic transformation of linguistic inputs through clearly defined rules is remarkably similar to how modern computational systems process information. Sanskrit sentence constructions follows a Puraka theory which defines syntactic semantic rules like a agent, object, instrument, and others. What's significant here is that words function in a sentence is governed by semantic language rather than just its position. This structure maps closely to predicate logic used in artificial intelligence and programming. In this essence, the Sanskrit approach to sentence construction treats language as a logic system where meaning emerges from clearly defined relationships between elements. This perspective anticipated modern computational approaches to natural language processing by thousands of years. In Sanskrit, the verb holds central importance in sentence structure. Unlike some languages where nouns might take prominence, Sanskrit sentences revolve around the verb which defines the action type, tense, mood, number, person, and the roles played by the other elements in the sentence through the Karaka system. We can think of verbs as the processes in a sentence similar to functions in programming languages. They take inputs, subject, object, etc., process them according to defined parameters, and produce meaningful outputs. This verb-centered approach creates a systematic logic framework for understanding how sentences convey meaning. Sanskrit rule-based grammar systems offer significant advantages for creating machine-readable languages. This is why elements from Sanskrit linguistics are being utilized in modern computational applications. The systematic approach of Sanskrit grammar helps in developing syntax, parsers, semantic analysis engines, and compression ontology development. Interestingly, there have been notable projects like NASA Sanskrit Parser and various AI tools developed in India that leverage Paninian logic. The highly structured nature of Sanskrit with its clear rules for transformation and derivation makes it particularly valuable for computational linguistics researchers who are trying to teach computers to understand natural language. Sanskrit approach to language essentially anticipated many of the challenges and solutions we are still working with a modern NLP. To summarize, what we have covered in this video is that Sanskrit grammar offers a structural logical language model that demonstrates remarkable sophistication. The concept we have discussed, rule-based generation, semantic tagging, and phonetic classification, all predate modern computer science by thousands of years. Yet they address many of the same fundamental challenges we face in computational linguistics today. Sanskrit essentially forms a bridge between traditional logic system and a modern AI and NLP frameworks. As